Yellowstone National Park is perhaps most famous for its collection of geysers, hot springs, and mud pots. And the most popular of these geothermal features is undoubtedly the aptly named Grand Prismatic Spring with its stunning rainbow colors. But did you know that there are at least 10,000 hydrothermal features in Yellowstone? No, thousands more than the roughly 3,000 that we can easily see. In fact, the entire park sits atop one of the largest and most powerful geothermal systems on Earth. And understanding what lurks beneath the surface can help us not only appreciate the beauty of this amazing place, but also protect it for future generations. It was on this day, June 28, 1870, that the U.S. Congress signed a bill into law permanently protecting the Yellowstone region. But it would be another 40 years before Yellowstone became the world's first national park. These days, it receives about 4 million visitors every year to marvel at its natural wonders. Much of that comes during the summer when bison roam the lush green valleys, black bears forage for berries, and tourists take selfies in front of colorful hot springs. However, things are very different in the winter when much of the park is buried under snow, and most of the wildlife is nowhere to be seen. It might seem as though nature is taking a break, but that couldn't be further from the truth. That's because below the surface, the heat never stops. Yellowstone sits atop a massive magma chamber, so large that if it were a country, it would rank as the 20th largest by area. Now don't worry, even though the magma chamber is roughly 60 miles or 100 kilometers across, it is located more than 4 miles or 6.5 kilometers beneath the surface. So while a supervolcano lives beneath Yellowstone, scientists think that an eruption is not even remotely on the horizon. Instead, the magma chamber mainly serves as a heat source for the massive geothermal system that sprawls across the park. This network of interconnected cracks and fissures is responsible for nearly all of the iconic geysers, hot springs and mud pots that attract visitors from around the world. And its influence extends far beyond what we can see on the surface. Take, for example, Mammoth Hot Springs. You've probably heard of this place simply because it's one of Yellowstone's most famous attractions. The terraced platforms and sinuous rills appear to be frozen in time, but you'd be wrong if you thought that these seemingly static structures have always looked this way. That's because Mammoth Hot Springs is actually a very dynamic location. Take a closer look, and you'll start to notice small differences. For example, this mound wasn't here just a few months ago. Meanwhile, this feature has shrunk considerably since last year. Even this pool has filled in over the course of just a few weeks. What's happening here is truly remarkable. The water you see isn't hot spring water seeping out of the rocks. Instead, the water is actually freezing. As temperatures drop in the winter, water vapor condenses on the cool rock surfaces, which forms frost. Over time, layers of ice build up and eventually become so heavy that they break off, creating new terraces and altering the landscape in a matter of hours. To understand how this is possible, let's dive deeper into the geothermal features that supply Mammoth Hot Springs with its famous water. Yellowstone's geothermal features come in all shapes, sizes, and colors. At the hottest end of the spectrum, there are hydrothermal areas that reach temperatures above 250 degrees Fahrenheit or 120 degrees Celsius. These areas often feature deep pools of boiling water like the Dragon's Mouth. A little farther down the spectrum, you'll find features like the Black Sand Basin. Despite their lower temperatures, these basins are home to a wide variety of fascinating life, including the colorful bacteria that give them their unique appearance. Finally, you'll encounter cooler features that are too shallow to maintain boiling water, but are still warm enough to support unique life. These are known as hot springs. Many of the hot springs are similar to the Black Sand Basin, but others are much larger, like the aptly named Grand Prismatic Spring. Now, I already mentioned the Grand Prismatic Spring at the beginning of this video, but it deserves special attention. The Grand Prismatic Spring is the third largest hot spring in Yellowstone and the largest in the world based on surface area. But aside from being big, the Grand Prismatic Spring is also beautiful. The vibrant colors of the spring are caused by pigmented bacteria that thrive in different temperatures. And all told, The spring contains more than 10 billion gallons, or 380 million liters of water. All that water is supplied by more than 100 feet or 30 meters of underground pipes known as a lava tube. Now you're probably wondering where all this water comes from. And that's a great question because it's not exactly what you might expect. See, the water you see bubbling up in Yellowstone doesn't come directly from rain or melted snow. Instead, most of it is supplied by the mighty Yellowstone River. Here's how it works. The Yellowstone River flows through the park from north to south. But before it leaves the park's northern boundary, it dives underground. There it travels for 40 miles or 64 kilometers before re-emerging near the town of West Yellowstone. Along the way, the river soaks through porous layers of rock, which allows water to slowly percolate into the ground. From here, the water makes its way toward the park's central magma chamber. And as it descends, it is heated by the intense temperatures below the surface. Once the water reaches its boiling point, it travels back toward the surface along cooler rock layers. This creates a closed-loop system that circulates water from the Yellowstone River to the park's central magma chamber and back again. And the longer the water stays underground, the hotter it gets. So water from the Yellowstone River can emerge as warm as 200 degrees Fahrenheit or 93 degrees Celsius. That's why many of the park's hottest hydrothermal features are found along the river's path. So with all this water circulating through the park, it might seem like the system could go on forever. But that's not the case. As it turns out, the geothermal system is constantly losing water to the atmosphere. In fact, Yellowstone loses between 10,000 and 20,000 acre-feet of water every single year. That's enough to fill between 1 and 2 million Olympic-sized swimming pools. This loss of water is partly due to evaporation, but it's mostly due to seepage. For example, some of the hot spring water seeps into the ground and resupplies local rivers and streams. Others flow underground to re-emerge as springs outside of Yellowstone. One of the most well-known of these is the aptly named Fountain Paint Pot. Located near the southern entrance to Yellowstone, this spring is fed entirely by water that leaks out of Yellowstone's geothermal system. As water leaves the system, it's replaced by more cold water from the Yellowstone River, and that's why it's so easy to access the heart of Yellowstone's geothermal system. Basically, all you have to do is dig a few hundred feet or less. This makes Yellowstone a unique place in the world. There are other places on Earth with giant magma chambers beneath them, but almost all of them are dry as a bone. Yellowstone, on the other hand, has managed to keep its magma chamber hydrated for millions of years, allowing it to produce some of the most impressive displays of geothermal activity on Earth. But as we continue to learn more about the inner workings of Yellowstone, it is clear that the system is changing. We already know that the hot springs are getting hotter, and that may cause problems in the future. For example, one of the biggest threats to the delicate bacterial mats in Yellowstone's hot springs is temperature fluctuations. If the springs get too hot, it could kill off the bacteria that make these ecosystems so colorful. But that may be only the beginning. If Yellowstone's geothermal system continues to evolve, it could change the park as we know it. Take, for example, Norris Geyser Basin. This area is home to some of Yellowstone's most impressive features, including the powerful steamboat geyser and the beautiful porcelain basin. But the Norris Geyser Basin is much more than just a pretty place. It is also a window into the future of Yellowstone. That's because this basin is home to more than 100 recently discovered hydrothermal vents. These vents emit gases like carbon dioxide, hydrogen sulfide, and methane. Some of these gases escape directly into the air, while others fuel microbial life in the basin. But no matter how they manifest, these gases are signs that the geothermal system is changing. That's because gases like carbon dioxide and hydrogen sulfide are produced when rocks react with hot water. In other words, the increasing temperatures in Yellowstone's geothermal system are causing new reactions to occur, which produces these vents, and that could be a sign of bigger changes to come. If Yellowstone's geothermal system continues to get hotter, it could trigger seismic activity in the region. This could lead to earthquakes that reshape the landscape and alter the park as we know it. That's why it's so important that we continue studying Yellowstone's geothermal system. By learning more about what lurks beneath the surface, we can better protect this amazing place for future generations. In the meantime, though, we can enjoy the stunning beauty of Yellowstone National Park. Whether you prefer hiking through its verdant forests or relaxing in a cozy cabin, there is no shortage of ways to experience this natural wonderland. Just be sure to leave no trace of your visit so that others can enjoy it for years to come. Hey there, thanks for coming on this journey with me as we explore the Yellowstone caldera and learn about the amazing geothermal features that make this park so special. If you want to see more videos like this, be sure to subscribe. I hope you learned something new. Until next time,